Hello everyone, I am D.M.KALAI Selvi, Assistant Professor, CSE Department, R.M.D. Engineering College. Subject code 21CS502 Artificial Intelligence. Fifth semester, the academic year 2023 to 24. Now we are going to see how to represent a knowledge into a AI system. So as a human being, we will get knowledge based upon the things we observe from the surroundings and we based upon the ideas which we given to us by our parents or by the societies, and based on that we will take a decision. But if you take a computer system, or an AI, a machine, which will take its own decision based upon the stored data, and it will take its decision based upon the label and features on it. So the decision making is done by the computer on itself. So for doing that one, the computer needs the knowledge. So how we are going to represent the knowledge will be come into picture. There are many ways. So one of the way is proportional logic. So proportional logic, if you represent a sentence that can give the answer either true or false. So proportional logic will work only for Boolean statements, like whether the answer for that question or the sentence will be either true or false. For example, 3 plus 3 is equal to 7. So the statement can give the answer either true or false. So this type of sentence is proportional logic, and it not easy to represent all the sentence in the form of a proportional logic, that is with answers or like yes or no. Sometimes you can get an answer more than a yes or a no. For example, mangoes or sweet. We can't say it's yes or no. Some mangoes will be sweet, some mangoes will not be sweet. So in that case, we can't give a proportional logic. And that time, first order logic will come into picture. So first order logic will deal with sentence with uh, with the quantity of the variables used in that sentence. So we can say it as a variables or objects or constants or elements. So based upon the quantity, we will put the connectives and then frame a sentence. So that type of sentence will be first order logic or predicate sentence. So for doing that one, we need a quantifier. So quantifier is actually a language element, so it which is used to specify the quantity of the specimen which we are going to use. So it will determine or it will identify the range or the scope of that variable in the expression. So we have two types of quantifiers: universal quantifier, extensional quantifier. So universal quantifier will be used for the terms like everything, all, for all, like that we are considering the union of every items in the universe. So if it is an extensional quantifiers, we are going to consider only a small amount, some few, like that. In that cases, we will using extensional quantifiers. So quantifiers, for representing universal one, we use the variable symbol V, symbol for all, and for extension we use the inverted E. For example, we given a sentence like all employees. So this sentence can be represent, instead of all ALL, we are using the symbol V, and X represents the entire specimen. So X is a quantity, I mean object, which for all X, that means for all the X in the universe. Okay, so employee, so employees are converted into the relation MP, employee of X. So X belongs to, X is a object, belongs to all items for all, and that X should be an employee. So for if you're taking for some students, so X is a variable and that X, for some X, student is a relation. That is, some X is a student. Now we are going to convert the sentence into a first order logic using quantifiers. If you are taking this word sentence, all birds fly. So we are going to first we declare a variable X. So what is the specifier they are given here? Quantifier all. So we give for all symbol here. So for all X. So the function or a relation, we can say it as a birds. So X should be a bird. So the first condition, so the entire statement is like a if else. So what the question they are sentence they have given, all birds fly. So X should be a bird. So bird of X. And if it is true, then it will fly. Fly of X. So that the set for X is for all. For all X items in the universe. If you take this sentence, every man respects his parents. So here the predicate, you can say it as a predicate, relation or a function, all are same. So if you're taking, here the predicate is respects and man. So if you take for all X, because they are given this term as every man, that means all. For all X, that X should be a man. X should be a man. If X is a man, then it will call another predicate respects. Respect X comma parent. That X should respect his parent. So if X is a man, then that X will respect his parent. Next is some boys play cricket. We are given the quantifier as some. So we will be using extension quantifier some X, and then a boy is the predicate, so that X should be a boys. So if it is true, then we go for play predicate, playing a game called cricket. So that X will play cricket. Next, not all students like both mathematics and science. So here you will be having student. What they are given, not all. First, we will be considering only all. So for all X, that X should be a student. So this term will be for all X and that X should be a student. If it is if X is a student, then that person will like, X will like mathematics and X will like science. Here they are given in the question, they are given and. So here we'll be using and. And at last, we are given the negation symbol. That means not all students. So if you are for avoiding this one, that means the without negation, the statement will give the meaning as the expression will give the meaning as all students like both maths, mathematics and science. But they the question they are given not all. So for giving that not, here you will be given the negation. Next example is only one student failed in mathematics. So if you take this one, only one. So if you with this word we going, what does it mean is we are going to use extensional quantifiers. So for some X, that X should be a student. If that X is a student, he will fail in mathematics. So X comma mathematics. That person will fail in mathematics. Or if you can also represent this with for all subject Y and Y equal to X, which is not true. That is X and Y are not true. And the student of Y failed in, not failed in mathematics. So this entire thing will be that is we are showing that Two side if we are using negation symbol. If not, then false. That means it is true. In that sense, we are using this term. Some more example. Sam is tall. So tall is the predicate. Tall. Who's tall? Sam. So tall of Sam. Next, John like crickets. Like is the predicate. So John, instead of that variable, we are using X. Instead of X, the variable, we are using John. Likes what? Cricket. Then everyone likes cricket. So everyone is replaced by the quantifier. Likes is the predicate and X is this variable name is replaced by X, comma, cricket. So this is X can be anybody, Sam or John, anything, any name you can use it. So now in this sense, we are changing a FOL, first order logic to a using the quantifiers, we are increasing the quantity of the variable. Next, all students like cricket. So if X is a student, first the condition is if X is a student. If it's so, for all X likes X comma cricket. Next, some boys are intelligence. Some boys. So for some boys, we are representing using extension symbols. Then that X should be a boy and that X should be intelligent. Some integers are even and some are odd. So for some, you are representing using extension quantifiers X, even, X, or X, odd, X. Next is, sorry, not or, here they have given and. So and, for that we are using and. Next is, not all students like both mathematics and science. First, for all, we will be taking, that is, we are going to represent only the positive work first. For all X, student of X. If X is a student, then that likes, like predicate, X likes mathematics or and in the question they are given both mathematics and science. So and likes science. So X likes science. Here for not we are giving the negation symbol. If you take this example, so here a model with a crown which will be on the head and left leg as left leg, right leg. So it's a representation of a person. So the objects here, person, two persons are there. So J for John and another person Richard. And they are having a crown. L represent the left legs of both John and Richard. So the relations, what are the relations? So here are given relations or you can say it as a predicate. On head. So the crown on head will be called as the king. Both are brothers. So John and Richard are brothers and both individual will be called as a person and whose king? John is king. So these are the relations. No other person wears crown except the king. So what's the function? We can say yeah, only king will have the crown. So John will be the king and he will be having the crown. And John the king has a left leg with shoe. If you see Richard does not have a shoe. So it's a simple example of showing a model using a proportional logic. Thank you.